Hello YouTube. In this discussion, we are going to be looking at numerical integration. And the numerical integration looks at an approximate integral, whereas the direct integration looks at exact integral. So what does this numerical integration helps us to do? It helps us to approximate the area of a curve, okay, area under a curve, and of course also is an application to integration. So now we are going to be looking at a number of methods, and in this discussion we are going to be looking at trapezium rule formula. So how to apply the trapezium rule and how to derive it is going to be part of this discussion. So for a function f of x over an interval a to b, a and b inclusive, the trapezium rule approximates the integral f of x from a to b, okay, with respect to x is going to be approximately equal to h out of 2 into f of x naught plus twice the summation of f of xi, whereby I is equal to 1 up to I is equal to n minus 1. Then we add there f of xn. So whereby h is what we are calling the width of each subinterval, then b minus a out of n is how to get that h. Then xi are called the intermediate points, x naught is equal to a, and xn is equal to b are the endpoints of the interval. Okay, so that means this is going to be x naught to xn of f of x dx. Okay, so that's what it means. And then we are saying the steps to apply this is going to be dividing the interval into n equal parts, and n is what we are calling subintervals. Now n, okay, n plus 1 are called ordinates. So n plus 1 are called ordinates. And those are going to be the number of x points that you're going to use to get the various parameters that you are going to use, or the various values that you're going to substitute in the trapezium rule formula, and be able to estimate the approximate integral or the approximate value of the area under a curve. Then calculate the values of the function at each of the n plus 1 points. Okay, so these are the ordinates that we are talking about. Ordinates are going to be x0, x1, x2, up to xn. So apply the trapezium rule formula and then use this to determine the sum of the areas of the trapezoids formed by these functions. So now we shall be looking at a function, and we are going to approximate this function. We are going to approximate its area, and the area, of course, it impounds maybe between it and the x-axis or between it and the y-axis. Then we will be able to divide that area into a number of strips, which each strip represents or approximates a trapezium. And this is how we shall be looking at it. So we are looking at, if I divide the whole area into a number of strips, and each approximates to what we are calling a trapezium, then we will be having your h here. Okay, then remember, in the usual trapezium we have let me say y, maybe y1, y2. Okay, so area of this trapezium a is going to be h out of 2 into y1 plus y2. So this is what we are going to be using to approximate the area under a curve using the trapezium rule formula. So now consider a function f of x. So let us assume that is our function f of x, and that function we have our x naught, we have x1, x2, x3, x4, x5, maybe x6. So here we are considering 7. We are considering 7 ordinates. So here we are looking at 7 ordinates. Okay? So what would be the corresponding values of y? The corresponding values of y from here to here, that will be y naught. This is y1, y2, y3, y4, y5, and y6. So remember, this is the function f of x, and that is x values. So applying the concept of area of a trapezium, I will be having area here. I have area A1, area A2, A3, A4, A5, and A6. Okay, maybe I can just still say this is area A naught. Okay, let me leave it for consistency purposes. I say A naught, A1, A2, A3, A4, that is A5. So my area of the whole, the area of the total area under this curve, if I'm considering from x naught to x6, then this is going to be area equal to area A naught plus A1 plus A2 plus A3 plus A4 plus A5. Okay, and what is A naught? So A naught, we said, obviously this is going to be h out of 2 into, okay, into, remember this is approximate, so it is going to be approximately h out of 2 into, this is y naught plus y1. Okay, so what we do, we are going to total the whole of this, and this is going to be A is equal to h out of 2 into, so I'm going to just sum the rest, because I know h out of 2 is going to be common. So this is going to be y naught plus y1, then plus y1 plus y2 plus y2 plus y1 plus y3, so plus y3 plus y4 plus y4 plus y5 plus y5 plus y6. So what do I see here? I see that y1, y2, y1 is 2, y2 is 2, y3 is 2, y4 is 2, y5 is 2. So A is going to be approximately, okay, h out of 2 into y naught plus 2 into y1 plus y2 plus y3 plus y4 plus y5, okay, then plus y6. So A is going to approximate to h out of 2 into, how do I summarize this? I will summarize this by saying, if I'm looking for the area under a curve using the trapezium rule formula, it is always going to be the first value of f of x, okay? So first value of f of x, okay, plus the last value of f of x, last value of f of x, okay, plus twice of the intermediate values of f of x. So I can also say this is approximately h out of 2 into, this is going to be f of x naught, okay, plus f of xn plus the sum, okay, of f of xi, okay, whereby xi are intermediate points from I is equal to 1 up to I equal to n minus 1, and I multiply this by. So this gives me what we are calling the trapezium rule. This is the trapezium